Welcome to The Explainer. Today, we're telling the story of the most overlooked, yet maybe the most important, star in the entire universe. A star that holds the secret to something like cosmic immortality and the ultimate fate of everything.
So it all starts with this huge cosmic question, one that really gets to the heart of our story today. We tend to think of stars as being born, living their lives, and eventually dying. But what if some stars could actually cheat that cycle? To even begin to answer that, let's get a little perspective. You've got these massive blue giants, right? They burn out in what's basically a cosmic flash, just a few million years. Our own sun, well, it has a respectable lifespan of about 10 billion years. But the red dwarf, its lifespan is on a completely different scale. So, let's properly meet this cosmic underdog. It's not big, it's not bright, but here's the thing. It is, by far, the most common type of star in our galaxy. And as we'll see, maybe the most significant one, too. Okay, check out this fascinating contrast. Red dwarfs make up a staggering 75% of all the stars in the Milky Way. 3/4 of them. And yet, they are so tiny, so cool, and so incredibly dim that not a single one is visible to your naked eye from Earth.
I mean, just think about that. The very closest star to our own solar system is right there, and we can't see it. This dimness, though, it hides an incredible secret power. It's the key to an astonishingly long life.
So how do they do it? How do they achieve this crazy longevity? Well, their secret isn't about how much fuel they have, but about their incredible, unparalleled efficiency in using that fuel. The key is a process called full convection. See, unlike our sun, which has all these distinct layers, a red dwarf is constantly churning its material from the very core all the way to the surface and back again. Just imagine a pot of boiling water that's always being perfectly stirred. This actually reveals how surprisingly inefficient a star like our sun is. It only burns the hydrogen that's right there in its core. That's only about 10% of its total supply. After that, the helium ash from fusion builds up and kind of poisons the reaction. But a red dwarf, thanks to that constant mixing, gets to use nearly 100% of its hydrogen fuel.
And what does all this incredible efficiency get you? Well, it leads to lifespans that are just almost incomprehensibly long. They completely rewrite our whole sense of cosmic time.
The smallest, most efficient red dwarfs are predicted to live for up to 10 trillion years. That is not a typo. 10 trillion years.
To really try and wrap your head around that number, think about this timeline. The entire age of our universe, from the Big Bang all the way to today, is just a tiny little blip. It's barely even a rounding error in the lifespan of a single red dwarf.
And this leads to one of the most amazing facts in all of astronomy. Our universe simply isn't old enough for even one red dwarf to have reached the end of its life. Every single one that has ever formed is still shining today. They are all still basically toddlers.
Now, this incredible stability and longevity makes them prime candidates in the search for extraterrestrial life. But, and it's a big but, it's also sparked this fierce debate among scientists. Are their planets potential havens, or are they deadly traps?
First off, the good news. Statistically, red dwarfs are our best bet. Current estimates suggest they host the vast majority of rocky planets in the habitable zone, that sweet spot where liquid water could exist. We're talking tens of billions of these planets in our galaxy alone. But this creates a classic cosmic trade-off. The promise is absolutely immense. Trillions of years of stable energy gives complex life a huge window to evolve. The peril, though, is just as great. These planets have to orbit so closely that they're likely tidally locked, with one side in perpetual daylight and the other in endless night. They also get blasted by intense radiation flares that could sterilize a planet's surface. But, nature often finds a way. A thick atmosphere could maybe circulate heat, creating a habitable ring in that twilight zone between day and night. A strong magnetic field could shield the planet from those nasty flares. And of course, life could always retreat to the safety of a subsurface ocean. The possibilities are still very much on the table. So this brings us to a final, really profound idea. What does the red dwarf's incredible lifespan actually mean for the far, far future of the cosmos itself? In the deep, distant future of the cosmos, a future so remote it's hard to even imagine, when all the big, bright stars are gone, when our sun is just a cold, dead cinder, red dwarfs will still be shining. They will be the very last lights burning in an otherwise dark and empty universe.
It just leaves you with a whole new appreciation for these quiet, unassuming stars. They teach us a powerful lesson about the cosmos, that true endurance, true cosmic immortality, it doesn't belong to the biggest or the brightest. It belongs to the most patient and the most efficient. They are, without a doubt, the ultimate survivors.